All right, so this is my solution, my video solution to example 3. See if I can get through it without any major screw-ups. And the bottom line is we have 65 questions left because I knew 35 questions, and the probability of success is 0.2, therefore the probability of failure is 0.8 because there's 5 questions on each. And I need at least 15 to pass, which means 15 or 16 or 17 and so on, not exactly 15. First, we should really check the conditions. We're only supposed to use this normal approximation to the binomial if the number of trials is bigger than or equal to 30, which this is. Also, n times p and n times q are both supposed to be greater than 5. And here they are over here. And they are both clearly greater than 5. So bottom line is it's okay to use the normal approximation. When we do this, we have to do a couple of calculations. We have to figure out the mean, all right? And we use the Greek letter mu for this, which is a big M, a funny M, and standard deviation. So we've done those two calculations. And by the way, the mean should make sense, because if you guess on 65 of them, you should get 20% of them right on average, and 20% of 65 is 13. Now, I'm going to draw a diagram here. And this would be the x. And I know that the mean should be 13. We just did that. And what I'm going to do is I'm going to draw the bar, so to speak, representing 15. In other words, this bar and all of the other bars, when I was doing this other video you may have listened to, it's referring to the bars, as in the bars from the bar graph / histogram. And if this is the 15 bar right there, then the left side of it starts at 14.5 because it's that bar and anything to the right. In other words, this is the area we're looking for. So that's one of the keys, is the fact that greater than or equal to 15, but we have to take or start at the left-hand side of that bar. So calculating Z, that 14.5 is what we're going to use for our x value. 13 is the mean, and the standard deviation from above is 3.22. And when I calculate this, I get roughly 0, oops, changed color by accident. 0.47. This is a key value. And remember, we want the area to the right, all right? So we look up 0.47 in the table. And I'm going to bring up my table. You can't see me doing this. But 0.47 is 0. Just a minute here. 1 minus the probability that Z is less than 0.47. This is what we look up. And when I look that up, I get 0.68082. And when I subtract those, I get 0.31918. Now let's go back to our diagram for a second. I don't just make you draw diagrams because I'm a mean old math teacher. Does it make sense that this part over here, the part to the left of Z equals 0.42? And by the way, I'm going to put 0 right there and 0.47, sorry about that, 0.47 right there. and these would be the Z values. It makes sense that in here would be 60-something%, and the area that we want over here would be 30-something%. So do look back at your diagrams to make sure that what you're doing and what I'm asking makes sense. So your final thing would be to make a statement, and you can say the probability is 31.918 of getting 15 or more, or you can say it's 31.9, I'm going to round to one decimal here, %. Okay, and that's it.